guys, so before we start the new material for today, I do want to go back and look at page 9 in the packet. On page 9, there's a bunch of questions that are there for you, relating everything back to the unit circle. And basically all the questions that are here are about things that you already know, but they're asked in a different way. So I just want to make sure that you really understand what all information is on the unit circle and how you can locate certain things. Because as you know, later this week, and actually very soon, you're going to be expected to know the unit circle, period. So you do need to know what all is on there, all the radians, all the degrees, and all the coordinates itself. So what better way than to answer all these questions, right? So we're going to go in. Number one is fairly simple. Number one should look very familiar to you, actually. There were some questions on your assignment in the past that went over things like this. So number one says, determine a point. In other words, what is a coordinate on the unit circle at the angle 7 pi over 4. So if you take a look, notice that 7 pi over 4 is a pi over 4 family member, which would be right over here in the fourth quadrant. And because it's a pi over 4 family member, it's actually very easy because all of the pi over 4 family members have the same exact coordinate, just like the other families, they have their own coordinates. But for pi over 4, your coordinate is root 2 over 2, comma, root 2 over 2. However, we have to be really careful because we're in the fourth quadrant. We have to really pay attention to which signs we're going to have. So because we're in the fourth quadrant, our x will be positive because you're going to the right, so positive x. But then we're going down, so that tells us we're going to have a negative y. So for 7 pi over 4, your coordinate or your point is root 2 over 2, comma, negative root 2 over 2. All right, number 2 is asking for you to find which quadrant your angle is going to be in given these conditions. So it's written a little bit differently. So let me break this down for you. Number 2, part C, is where I'll start, and then we'll go back from there. And we'll just kind of mix up the order from simplest to hardest. Part C asks for sine of some angle. So in other words, where is sine of any angle greater than 0? So remember, sine refers to your y value. So in other words, where is sine, or your y value, greater than 0? And remember, all numbers that are greater than 0 are basically just positive. So in other words, where is sine, where's your y value, a positive number on the unit circle? A positive y is going to all be above the x-axis, so the quadrants that are of question are quadrants 1 and 2. So we would simply say that sine is positive in quadrants 1 and 2. And that's your answer. Okay, let's look at part D. Part D is asking about sine and cos both, and it's saying where is sine of any angle equal to cos of any angle. Now if you think about it, on the unit circle there's only one family that has both x and y as the same fraction, or the same number, and that's the pi over 4 family, just like we saw up here. The numbers are the same, the only thing that changes is your sign. So now, paying attention to signs, where is sine and cos the same? Signs and all, numbers as well. So if we know we're going to pay attention to the pi over 4 family member, we know here in the first quadrant everything is positive. So we have root 2 over 2, comma, root 2 over 2. But in the second quadrant, we know we have a negative x and a positive y, so that's not going to work. In the third quadrant, we have everything that's negative, so we have negative root 2 over 2, comma, negative root 2 over 2, so that'll work. And in the fourth quadrant, that will not work because your x is positive there, but your y is negative. And so that's not going to work. So the only two places where sine and cos are the same value, where your x and y are the same value, are in quadrants 1 and 3. So that's what we'll write down. Quadrants 1 and 3. And that's it. So now going back to part A, part A is asking about two things. So they both have to be true, and that'll really restrict where you're looking. So first thing is where is sine positive? Well, we just did that in part C. We said sine is positive in quadrants 1 and 2. Now it's saying on top of this, where is cos positive? So now cos, remember, is an x value. So if we look at that, cos, or in other words, x is positive all on the right side. And the right side is all quadrants 1 and 4. So cos is positive in quadrants 1 and 4. Oops. So now what it's asking, let me actually rewrite that, sorry. 1 and 4, there we go. Now what we need to do is see where they overlap. So where is sine positive and cos positive? And the only place that's true is in quadrant 1, because those conditions overlap only in quadrant 1. So that's our answer, quadrant 1. Okay, part B tells you that you want tan that's less than 0, so tan is negative. And if you think back to how you find tan, remember it's always sine of any angle over cos of any angle. And if we want tan to be negative, that means either sine or cos will be negative. So that's only the case in quadrants 2 and 4, where sine or cos is negative, not both. Okay, so there's for tan. Now for cos, where is cos positive? Cos, we said just in the previous example that cos is positive in the first and the fourth quadrants on the right side. So again, the only place these two conditions overlap is in the fourth quadrant, and that's your answer. Okay, looking down at the next section, now you're given these angles that you should recognize are all on the unit circle except for this one, but that you can reach after revolutions. Try that one out and see if you can find the answer. But what it's asking for, and I'll just start off with number 3, 7 pi over 6. What it's asking for is for you to find sine, cosine, and tangent of that angle. So take a look and see if you can figure out where 7 pi over 6 is. So 7 pi over 6 should be right over there. Check and see. Hopefully you got that right on your first guess. But there's 7 pi over 6, and if you pull out the coordinate for your pi over 6 family members is root 3 over 2 comma a half. But again, because we're in the third quadrant, we know everything is negative, so we're going to have to throw a negative in front of the x and a negative in front of the y. So there's my actual coordinate for 7 pi over 6. Now that's not what it's asking for. Really what I'm being asked for is more specifically, what is your sine value of 7 pi over 6? What's your cosine value? And what's your tangent value? So let me write that down. So I want sine of 7 pi over 6. And sine, remember, again, is only your y value, so I'm just going to put down it's negative a half. So there's that. Cos of 7 pi over 6 will be your x value, so negative root 3 over 2. And tangent is always the one that requires a little bit more work, because tangent is, and I'll do it right over here, sine over cos, and we just found both of those, so it's not so bad. Sine is negative a half, cos is negative root 3 over 2, and to simplify that, I'm going to multiply my first fraction by the reciprocal of the second. So there's that. Two good things happen. Our negatives become positive, and our 2's cancel, giving us 1 over root 3, but the problem is the square root at the bottom. We do have to rationalize, and once we rationalize, you'll end up with root 3 over 3, and that's your tan value, your tangent value. Okay, let me go to number 9. So number 9 is asking about 2 pi, and if you remember, hopefully you do, 2 pi is the same thing as 360 degrees. So really, we're looking right over here. After one revolution, of course. But here's 2 pi. Now here's the thing. see if you can figure out the coordinate. I'll give you just a few seconds. See if you can figure out the coordinate at 2 pi. So your coordinate should be at 1, 0. And if that's the case, then yes, you're right, we don't have any fractions, and it looks kind of strange because everything else is typically in fractions. But that's still our coordinate, and that's still x comma y. It's still our cos comma sine. So if I ask you for those same things, if I ask you for sine of 2 pi, then I'm still just looking at my y value, which in this case is 0. If I ask you for cos of 2 pi, I'm still looking at my x value, which is 1. Tan of 2 pi is still sine over cos, in this case, 0 over 1, which is 0, and your tangent value is 0 then. Okay. The other examples will work out the same way. So try those out and check online for solutions on that. And the last section on page 9, you're given, it's almost going backwards. So you're given the you're given the point, the value, and you're asked for the angle. So you're going backwards. So number 11, let me translate that for you. So basically it's saying, what is the angle where sine is root 3 over 2? Okay, so if you think about that on the unit circle, in other words, where is your y value on the unit circle where your y value is root 3 over 2? So we know, just by knowing the unit circle, that this right here at pi over 3, which is 60 degrees, pi over 3, your coordinate is 1/2, comma, root 3 over 2. And that is really what we care about right there, because it's asking for that. So we know that one of our answers is going to be pi over 3, or you can say 60 degrees if you'd like. But we also have another answer, because where else is sine a positive root 3 over 2? Yeah, so sine is positive right up here in the second quadrant as well. So now think about, what is a pi over 3 family member that's up here? And if you think about that, it is 2 pi over 3, which has the same points. And our y value is still positive. Our x value is the only thing that's negative there. But it still counts as an answer. So we're going to say that theta is pi over 3, or 60 degrees, and, I'll actually write and, 2 pi over 3, which is 120 degrees. So you actually have 2 answers for that one. Okay, I'm going to skip all the way down to number 14. Number 14 is asking for, what's an angle where tangent is undefined? And just to kind of go back over that, undefined will be your tangent, or actually undefined is an answer whenever you have 0 at the bottom of a fraction. So now I'm going to make you think about that, because if you know tangent is sine over cos, then for what angle is this true? Think about that. Pause this video and try that out, and I will have the solution online for you, so check that out at a later time. Okay, so that's page 9. So be sure you're able to answer questions like that. Now what I'm going to do is I'm going to flip our attention to our actual new material, which is page 15. So let's go ahead and go to page 15. So everything that we talked about on page 9 and everything that we've talked about so far, it's been on the unit circle. But now I'm going to shift our attention and we're going to talk about right triangles that are not on the unit circle. So kind of a flip of mindset a little bit. Here's what's the same, and this is kind of nice. If I have a triangle, and you may even remember this from a few days ago, but if this is my theta, some angle theta, and I keep it very general, then again, this is my hypotenuse, which we called r, very generally, r for radius. This is my opposite side of theta, so this is opposite, and we called that your y value, and this would be your adjacent, which is the x value. Okay, so now if I go with that, and we kind of redo what we did last week, cos is simply going to be based on SOHCAHTOA, remember that? So cos is going to be adjacent over hypotenuse. So in this case, adjacent is x, hypotenuse is r. Okay, now what's new for you is this right here, reciprocal functions. So not only do you have trig functions, you also now have their reciprocal. So each trig function has its own reciprocal. So the reciprocal for cosine is called, and I'll write this out for you, that's the shorthand, it's really called and it's pronounced secant. So cos and secant are reciprocals. So now, knowing that it is a reciprocal, all we have to do is take the reciprocal of that, so that's going to be h over a, which in this case is r over x. Okay, sine, according to SOHCAHTOA, is opposite over hypotenuse. In this case, it's going to be y over r, and the reciprocal for sine is called cosecant. And again, because we know it's a reciprocal, it's simply going to be h over o, so hypotenuse over opposite, in this case, which is r over y. Okay, and the next one, tangent, is opposite over adjacent according to SOHCAHTOA, which in this case is y over x, which we sometimes also write, typically also write as sine over cos. But its reciprocal cotangent is going to be its reciprocal, so it'll be adjacent over opposite, which in this case is going to be x over x over y, which is also the reciprocal of this right here. So cotangent will be cos over sine. Okay, so now keeping those things in mind, here's a really quick and easy way to remember this. Every single reciprocal pair that you have, just to keep these names straight because I know they can be confusing, the easiest one here is tangent and cotangent, right? Those are pretty easy to remember. But here too, notice that only one of those in the pair has the prefix co in front of it. If I look at the one above it, the pair sine and cosecant, only one of them has the prefix co in front of it. And the next one, cosine and secant, only one of them has the prefix co in front of it. So hopefully that'll keep it in order for you. So there's that. Now let's do some examples, and I'll just kind of do one of each so we can get straight to the point. So number one is what I'll do, and let me give you a triangle, and let's see where we can place the triangle. So if I give you this triangle right over here, and here's my right angle right there, and let's say here is theta, and I give you two of the sides, so I'm going to give you 8 and I'll give you 7. Obviously, these numbers are nowhere to be seen on the unit circle. So we know that the radius will not be 1, and actually we're going to have to find the radius, and if we're given two sides, we need to find the third. We do have to use the Pythagorean theorem. So a squared plus b squared equals c squared. So we have 8 squared plus 7 squared equals c squared. 64 plus 49 equals c squared. And go ahead and pause the video real quick and find c out for yourself. So you should find that c is the square root of 113, and you could find the decimal of that. I'm just going to keep it as the square root of 113. Okay, so now we know that third side, we know the hypotenuse is the square root of 113. So now what I'm going to do is, it's asking for the exact values, and it's saying exact because it wants you to keep it in square root form because that's actually the most accurate form that you can possibly give me rather than decimals. So find the exact values of the 6 trig functions. So I'm going to ignore this so we have more room to work. So I want sine of theta, its reciprocal, which from above, remember, is cosecant. Whoa, oh no. Cosecant. I want cosine and its reciprocal, which is secant. And I want tangent and its reciprocal, which is cotangent. So based on SOHCAHTOA, I can find these 3, but then all I have to do is reciprocate them to find the other 3 trig values. Now here's the thing. I need to really pay attention to the way this triangle is drawn, because if we don't, we're gonna miss something really, really important. Take a look at where this angle is. If you've been observant, you might have noticed that typically theta, the angle, is always nearest the origin. So if this is the origin, let's actually figure out where this triangle is, because we can't just assume that everything is always in the first quadrant. So if we really put it into perspective, we're actually in the 4th quadrant. And if you think about the 4th quadrant, then hopefully you'll realize that x is positive, but y is not positive. Y is actually negative in the 4th quadrant. So now we have to put in that negative. So really that's a -7 because we're in the 4th quadrant. Hypotenuse will always be a positive number because that's a distance. So now we're ready to go ahead and use SOHCAHTOA. So according to SOHCAHTOA, we're looking for sine. So sine is going to be opposite over hypotenuse. Opposite in this case is -7, and hypotenuse is root 113. Now again, the problem is the square root at the bottom, so we're going to have to rationalize. And once you do that, you'll have -7 root 113 over 113. And that is sine of that value. Okay, let me just go over and let's go ahead and do the reciprocal, find the reciprocal. So the reciprocal of sine is cosecant. And all I have to do is, I'm not going to go here because that's actually rationalized. Let me go back to the unrationalized, the original fraction, and just flip that because you'll see what happens. If I go ahead and flip that, it's already rationalized and I don't have to worry about it a single thing. So there's cosecant. Okay, the next one is cosine. And remember, cosine is adjacent over hypotenuse. In this case, adjacent is 8. Hypotenuse is root 113, so again I have to rationalize, and once I do, I'll have 8 square root of 113 over 113. So there's your cosine value. For secant, for its reciprocal, again I'm going to go back to the original fraction that I have and go ahead and flip that because again it is rationalized for you. So there's your secant. Okay, and the last pair, so tangent is opposite over adjacent. In this case, opposite is -7, adjacent is 8, and I can't simplify it, so I'll go ahead and leave it like that. And cotangent, its reciprocal, is simply going to be 8 over -7. There you go. Okay, the next part, let's go ahead and do number 4. So number 4 is giving you, just like we looked on page 9, it's saying where, at what angle is sine 3 over 4. And again, 3 over 4, hopefully you'll recognize that that's not on the unit circle anywhere. So we do have to go ahead and draw a triangle, and because this is a positive value, I'm just going to assume that sine is positive and sine is positive in the first quadrant, so I'm just going to go ahead and use that to my benefit. So if I know that sine is a positive 3 over 4, and I remember SOHCAHTOA tells me that sine is opposite over hypotenuse, I can go ahead and put down those values so that 3 is opposite and 4 will represent hypotenuse. So here's opposite, here's hypotenuse. And I do have to find the third side before I do anything else. And so I do need to use the Pythagorean theorem, so 3 squared plus b squared is what we're finding, equals 4 squared, so let's see, that's 9 plus b squared equals 16. B squared equals 7, squared equals 7, and so b is going to be the square root of 7. Okay, so there we go. And so now we're good to go. And it says find the other 5 trig value functions, the 5 other values. So we're given sine. Since we're given sine, let me write that down just so we have the format of it. Since we know sine is 3 over 4, then we can infer, we can determine that its reciprocal cosecant is 4 over 3. So there's another one for you. Now I need to find also cosine of theta. So now that I have all 3 sides, it's pretty easy. Cosine will be, according to SOHCAHTOA, adjacent, which is root 7, over hypotenuse, which is 4. And its reciprocal then, secant, will be the reciprocal of that, 4 over root 7. But we have to rationalize, and once you do, you'll find it to be 4 root 7 over 7. So that's your secant. Tangent of theta will be opposite over adjacent. So opposite in this case is 3. Adjacent is root 7. And we have to rationalize, so that'll give you 3 root 7 over 7. So there's your tangent. And its reciprocal cotangent will be the reciprocal. And again, I'm going to go back to the original fraction because once I flip that, it is already rationalized for me. So there are your 5 other trig values. Okay, let's take a look at number 7. So number 7 is actually giving you a reciprocal value. Now, what is that the reciprocal of? Yeah, it's a reciprocal of sine. So what I can actually go ahead and do is I'm going to go ahead and take that value right now and take the reciprocal of it so I can go ahead and find that. So here's the thing. Because this is not a fraction, I'm just going to go ahead and put it over 1. And if I reciprocate it, if I find the reciprocal of square root of 3 over 1, it's simply going to be 1 over square root of 3, which if I rationalize will give me root 3 over 3. So there's one of my values done. Now here's the thing. Now that I have sine, I can use SOHCAHTOA and figure out where it's at so we can find the other side of the triangle. So again, because I found out that sine is a positive number, again, I'm going to use that to my benefit and I'm just going to throw it on the first quadrant. So I'm going to say that's my angle, theta. And because I know sine is opposite over hypotenuse, opposite is the side right here, so square root of 3. Hypotenuse will be 3, and if I use the Pythagorean theorem, let's do that off to the side. I need to find, I'll call this side B. So let's see, we have square root of 3 squared plus B squared, we don't know, equals 3 squared. So 3 plus B squared equals 9. B squared equals 6, and B equals the square root of 6. So now we have all 3 sides, we're good to go. I've already found sine, so there's that. Now I just need 4 more. I need cos of theta, its reciprocal, which is secant of theta. I need tan of theta, and its reciprocal cotan of theta. So let's start from cos. Cos, remember, is again adjacent, so square root of 6 over hypotenuse. So there's that, pretty easy. Its reciprocal will be 3 over root 6, and after rationalizing it'll be 3 over root 6 over 6, and you can also simplify that. So that should simplify to give you root 6 over 2. So that's your secant value. Okay, tangent will be opposite over adjacent. So opposite is root 3 And adjacent is root 6, and we do have to rationalize, so just like this. And here's how this one works. So at the bottom you do end up with 6. At the top though, you keep the square root and you just multiply the numbers that are on the inside. So just like that. And of course you could simplify that, but that's okay, you can just leave it that way for now. And cotangent is reciprocal, will be 6 over root 18, which after you rationalize will give you 6 root 18 over 18. And that simplifies to give you root 18 over 3. Oops. Okay. And the very last example that we'll do, guys, is number 9 at the very bottom of that page. Number 9 gives you a random point. Again, notice that's not anywhere on the unit circle, and so again, we'll have to draw a triangle. And now notice that negative signs are given. So now think about where is your x value a negative number? So where do you have negative as an x, and where do you have y as a positive number? Where is x negative and y positive? Yeah, so it should be in the second quadrant where this is theta, and because we're given these numbers, what I can actually use to my benefit is this. So if I know that my x value is typically cos of whatever angle, and I know because we're not talking about the unit circle, I can actually rewrite, if you go back to the top of this page, we determined that cos is actually, very in general, is actually x over r. So if I follow that, then I know that x will be, on my triangle, x will be negative 5, and r is 13. Which is kind of nice. And if I do the same thing for my y value, y, remember, is sine of theta. And again, if you look back at the top of the page, sine is very much in general y over r. And if that's the case, then y is, on my triangle, 12, and again, hypotenuse is 13. So without the Pythagorean theorem, we actually have all three sides. Now all you have to do is find the 6 trig functions, which you can do again using SOHCAHTOA. And I'm going to stop there, guys. To find the answers on these unworked problems, including this one, please check online. I will have those all filled out for you. You can check your work. And we'll stop here. Until next time, bye y'all.